and welcome back to Codeblaze. So I'm back with voxel chunks in Unreal Engine 5, and last time we completed all of the declaration part, so the member variables and the functions. Now we will implement those functions one by one. So by the end of this video, we'll have something like this, where we'll have voxel meshes being generated as per our previous blueprint code. So let's get started. So we are going to start with by implementing the constructor. The first thing we do is add our include statements for the enums file, the fast noise light, and the procedural mesh component. Next, I disable the tick since I don't need it. And then I initialize the procedural mesh component using the create default subobject. Then I initialize my noise object, basically set the frequency. So this is something you can play with. Actually, all these three parameters you can play with and expose them as U properties if you want. Then I resize the blocks array since I know what the final size of blocks array is going to be, which is basically the cube of the chunk size. So it's better to resize it at once rather than it expanding during the runtime. And finally, I disable the shadows. So this is kind of a personal preference, since we would be going for baked ambient occlusion. So I want that effect to stand out more. So I don't want shadows right now. Again, this could be a U property, so totally up to you. So now we'll implement the utility methods, and the first one is the get block index. So it's pretty simple. So we're basically flattening a three-dimensional array index to one dimension, and first we'll move across the x-axis, then the y-axis, and finally the z-axis. So you can just consider this a three-dimensional array in which first the x-axis or the x dimension is filled, then the y dimension, and then the z dimension. And next method we implement is the get position in direction. This again is a pretty simple method. So depending upon the direction, we add that direction's unit vector to the position. And it should always be out of these 6 cases only. So by default, if it hits, though it shouldn't hit, we throw an invalid argument exception. And finally, we implemented this check method. So this basically checks whether the given position contains an air block or not. So if the given position's any of dimension is greater than the size, so that means we are checking something that's outside the current chunk, we return true because we want faces to be drawn in that scenario. Otherwise, we use the get block index to flatten the position to the proper block index, and we compare that with the air block. So if that block is an air block, we return true because in that case we want a face to be drawn. And if it's not an air block, then it's something solid, so we don't need a face in that direction. Now we'll implement the get face vertices method. So this method will basically query the block vertex data to get the 4 vertices. So we define a vertices array and have a for loop which runs till 4. And we basically add the correct vertex data. So the way this logic works is, so first we query the triangle data, right? We have the triangle data here. So depending upon the direction, so we cast the direction to an int and multiply that by 4 because there are 4 elements per direction. So with that, any one of this direction will come. And depending upon the I index, which is from 0 to 4, so considering the right direction, uh, the direction will be cast to 1. 1 into 4 will point to this element. And then I would be added, which is from 0 to 3, right? So that are the 4 elements, and we'll get these 4 indexes. And finally, we'll use these 4 indexes like 5036 to query the vertex data. So fifth would be this one. Yeah, fifth would be this one, then the 0, then the third, and finally the sixth. Oh, actually, fifth would be this one, but you get the idea, right? We'll use the triangle data to query the vertex data. So once we get that, we multiply that by a scale. So in our case, the scale is 1, so it wouldn't matter. And finally, we offset it by the current block's position and return that vertex array or the array of the 4 vertices. And this method is used in the create face method, where we are actually populating the mesh data. So we start with the vertex data and append the face vertices for the given direction and position. Next, we populate the UV data. So this is going to be currently this only. Once we start adding textures, this will change. So for now, we can just add in the simple squares UV data or faces UV data. And finally, we add in the triangle data. So do make a note of the initializer syntax that I'm using here. And the way we get the triangles is from the vertex count. And this is something I explained in my blueprint video. But the way this happens is depending upon the vertex count, we can offset the vertex count by these few numbers like 3 and 2 to get the two triangles for the given face. So if you need a proper explanation, I'll put a link to a video going over the anatomy of a cube down below, and you can go through it because that will explain in a much better way than I can. And finally, we increment the vertex count by 4 because every time a face is added, we are adding 4 vertices. Finally, we'll implement the get blocks and the generate mesh part. So for the generate blocks, what we'll do is get the current location of the chunk using the get actor location, and then we'll iterate in 2 dimensions, the x and y. So we'll basically be generating the height map kind of. So we get the x and y position for the map, so that we'll get by taking the x and y indexes of the loop, multiplying that by 100. So this multiplication by 100 is something specific to Unreal only, because Unreal works, the basic single unit in Unreal is of 100 centimeters. So we need to multiply stuff by 100. So we multiply x by 100, add in the location that is the offset of the current chunk, and divide this by 100. Since we want to query our noise map or the height map using this, the single steps in integers like 1, 2, 3, 4. That's why we divide again this by 100. So we don't have that Unreal offset. Now you could skip this division, but then you'll have to play with the noise frequency. And I think you can still get a decent result. But yeah, this way we get the X and Y position, which we are going to use to query the height map. And the way we are doing this is by simply using the noise object and passing in get noise, to which we pass the X and Y value. Now get noise will return a value between -1 and 1. So we need to scale it for to the correct value that we want. So we add 1, and now the value will be between 0 and 2. Then we multiply it by half of size. So the final value out of all this would be between 0 and size, since like the 2 and 2 gets cancelled. And then we round that to an integer since we want proper steps because we are doing a blocky world. And just to be on the safe side, I clamp this value between 0 and size. So that way it doesn't go out of bounds, or so we don't get any out of array index errors. So once we have our height, we fill basically the blocks till the height with stone, and the blocks above height with the air blocks. And that is all we need to do to generate a blocks array. Next, we implemented the generate mesh. So this is also pretty simple. So we iterate through all the blocks in X, Y, and Z direction. And then we check if the current block is a air block or a opaque block. If it's an air block, we can just ignore it. And if it's something else, we basically store the position with just the loop indexes here. Next, we iterate over the direction enum. Now this order of the enum values is again should be the same in which they are declared and in which the triangle data has been declared. So we basically iterate through all directions for the current block, and we check if the position in that direction. So basically we are checking the neighboring 6 blocks around the current block. So if the neighboring block is an air block, we create a face, otherwise we don't do anything. And to create a face, we pass in the direction, and again we need to offset the position by 100 because of the unreal units. And with this, we have everything implemented except the apply mesh. And apply mesh is pretty simple. So with all our mesh data created, all we need to do is go to the mesh, and we can call the create mesh section method. Create mesh section, and we'll be creating the mesh section 0. Next, we pass it the vertex data, then the triangle data. Then you can pass in a normal, but we are not generating normals for now, so we'll pass in an empty array. So that would be an empty array of f vectors. So just like this. Next, we can pass in the UV data. Then we can pass in vertex colors also. So this is also something you can work with if you don't want textures. So we don't want this, so we'll again pass in an empty array here. So T array, and this should be of F color, an empty array for this. Next, we need to pass in the tangents. Again, we are not necessarily concerned with that. So again, a T array of F proc mesh tangents. So all these values, you can actually see the documentation of the create mesh section method, and from there only you'll get this. And finally, we need to pass in a bool value whether to create the collision mesh or not. So ideally you would want a collision mesh if you want your character to run around over your mesh, but for now we'll set it to false since, well, it's not needed for us. And with this, we have the complete chunk class implemented. So it's quite around like good 140 lines, and now we'll test this in the engine to see if it works. Now before diving into the engine and trying to figure out why it's not working, so make sure you actually call these methods in the begin play, which I totally forgot. So with the super begin play, we can call the generate blocks, then we generate the mesh, and finally we apply the mesh. So with all that, you can compile your code, and I just added the chunk actor to my world. Now if I play, I'll see my chunk. Actually, I spawn inside my chunk. So you can see we get our voxel mesh here. And if you are using the same frequency and the seed, you'll be getting the exact same mesh. And you can go inside and see we don't have any extra faces being drawn. And yeah, that's it. Whatever blueprint functionality we had to generate the mesh, we are doing that in C++ now. And just to have a little bit of fun, we'll create a world class which will allow us to basically instantiate multiple of such chunks depending upon the draw distance we set. So this is something optional, like it will be used in the future to test out the different meshing strategies, and it won't take much time. So just stick around and I'll talk about the next things coming up in the series. So here I have created a new class based on actor called chunk world, and this is going to be pretty simple. So first off, we again don't need the tick method, and we'll have some u properties here. U property, this one we'll have edit anywhere for now, everywhere. We don't need this extra braces. Edit anywhere, and we'll just apply a category that would be chunk world. Okay, and yeah, so the first property would be the actual class reference, so the reference to the chunk class that we want to initialize. So the way you store this would be t subclass of, and this can be actor only since the chunk is a subclass of actor. Now, this isn't the correct way to do it. Ideally, you would have a base class for all your chunk types and have that be the subclass here. But for now, we can work with this, and I'll just call it chunk. Next, we'll have another u property. Again, edit anywhere. The category would be chunk world, and this will be the draw distance. So we'll basically be drawing basically a rectangle of chunks around the origin. So we can have a draw distance, we can set it to 5 by default, and finally the last property would be the chunk size. So this should be the same value as what we have as the size variable in our chunk class. So we'll have chunk world, and this will be chunk size. So we have that as 32, and if we change it at that place, we need to change it here also. And that's all the properties we need. So you can go to the C++ class, we disable the tick, remove the tick method, and all we need to do is now do a two-dimensional for loop. Go from, we'll call this x, and it will go till the draw distance. This would be equal to, and this would be, it will start from minus draw distance to the draw distance so that it is all around. And similarly, we'll do another loop in y. So we'll change this to y everywhere. And now we just spawn our actor. To do that, we need to get the world reference. So get world dot spawn actor, and we'll use the first overload, which takes the u class property, and this will be an a actor. Again, if you have a chunk base class, that is what you need to use here. So this would be chunk, and then we need to give it a position, so that would be f vector, and this would be x into the chunk size, and it's not showing up, chunk size into 100. So that's the default Unreal Engine single unit. Similarly, we'll do y into chunk size into 100, and for now z can be 0. So that's our position, and finally we need to give it a rotation. So that can be 0 rotator. So f rotator zero rotator. Yeah. So that's it. With this, we'll have an basically a rectangular field of chunks being drawn around the origin. So let's compile and see it in action. So the code compiled successfully and I have added the chunk world to my scene. Next, we need to select the chunk class. So we'll just search here and we can find a chunk class. And for now, the draw distance can be 5 and the chunk size is 32, which is same as our size in the chunk class. Now, if I just play, so I'll have my chunks drawing. Actually, I'm spawning inside it. But if I go out, you can see we have our beautiful chunks spawning everywhere. So it's around the origin. So technically this would be an 11 by 11 chunk field. So around 121 chunks there are. And it's started pretty fine. Like the performance right now is pretty good. But then again, it can be a lot better than this with multi-threading and greedy meshing and all. So yeah, that's it for this video. And you can see we have culling also by default from Unreal Engine. And in the next few episodes, we'll start by implementing greedy meshing. So that's a better meshing algorithm. Currently, we are doing very simple meshing to generate these chunks. With greedy meshing, we can get a more optimized mesh, which will reduce the number of vertices and triangles. And yeah, from there, we'll go to textures, I suppose, and finally to ambient occlusion. Also, I plan to like have been getting comments regarding some other meshing algorithms that people want to see, like marching cubes or something like that. So yeah, we'll look at that also. So thanks for watching. If you have any suggestions, please leave them down below in the comments. Subscribe for the upcoming content, and your feedback is always appreciated. Bye.